Yeah, good morning.
Thank you very much. My name is Padi, Aeromet Safety Inspector of the Ghana Civil Aviation Authority, and I'll be presenting on the current African weather systems and their effect on aviation. I was working with GMet for some time, for about 2 decades, and I switched to Ghana Civil Aviation Authority. So the overview, we'll be looking at some introduction. We would look at some general weather conditions, the Earth's rotation, and some of the hazards that affect aviation. In order to draw the attention of listeners and viewers, we will look at the hazard at the early part, and we will now look at some of the weather conditions. So in the aviation industry, we have service providers and users. So on this screen, we could see a pilot and safety inspectors. So the pilot is a service provider, just as GMet is also a service provider. All these people have a particular aim of safety. So as an inspector, aviation safety inspector, you have to take surveillance of the services that are provided and write a report on it. Wherever there are findings or lack of some activities, you make sure that those activities are put in place in order to provide safety information and services to the customers. So some of the hazards which we commonly experience in Africa here are lightning. Almost on daily basis, there used to be lightning somewhere over the continent. Thunderstorms, they are daily activities that really affect flight operations one way or the other. You can look at also tropical cyclones, turbulence, clear air turbulence, jet streams, wind shear, heavy rain, hail. There are times we experience hail in Ghana here, and it's used to be, it is very dangerous to flight operations, as we'll be seeing. Line calls, we look at the importance of visibility, what can reduce visibility. We look at fog, mist, harmattan, or haze, dust storms. Then we look at cloud seeding and flooding also on the runway. Then we look at space weather, how the can affect flight operation or can affect the aviation industry. Recently, these are the types of weather conditions that we experience over Ghana. On the West African sub-region, we know or usually storms from west towards the east. But there are times also when storms move from the west towards the east, as we are seeing now on the screen. So as a meteorologist or as a weather forecaster or observer, you should know when or where the storm is moving so that you use it as a guide in providing your information. So lightning, when we look at lightning, it's a spark of light that comes from the atmosphere. And when it strikes an aircraft, it can also affect the structural body of the aircraft. Thunderstorms are also, lightning comes from thunderstorm. The thunderstorm itself, as we see on the left side, see lightning coming out from it and how huge the cloud is. But looking at the life cycle of the thunderstorm, it starts from a cumulus cloud. And at that time, there is updraft or upward motion of air to help in growing the storm. When it reaches the mature stage, like in about 30 minutes, we have upward currents and downward currents in that same cloud. So how dangerous this cloud is that when an aircraft is flying and encounters the matured CB, the cumulonimbus cloud, at the beginning, there will be an updraft, which will try to lift the aircraft. But within a short distance, there is also downdraft, which will push the aircraft downward. And that is why it is very dangerous to fly below the thunderstorm. And at the dissipating stage, we experience only downward motion of air. So it's very dangerous to fly under cumulonimbus clouds. So the best is to avoid such clouds. We also experience tropical cyclones in Africa, especially between Madagascar and Mozambique. Recently, about a month ago, that area sustained active tropical cyclones, which devastated Mozambique and Madagascar in just recent times. So flying an aircraft around those areas would be very dangerous because of very strong winds that will be encountered. Then, in flying, one dangerous aspect is the wind shear, a sudden change in wind speed and direction. So what happens is that when an aircraft encounters a cumulonimbus cloud, a thunder cloud, close to the runway, so you could see on the right, left, down corner below, you could see the runway. And that is the intention of the aircraft trying to fly along this straight route to the runway. But when it encounters this cumulonimbus clouds, it's very dangerous. At that time, if you are not able to recover under the cloud, then it's very likely that you will crash. So it's very advisable to avoid cumulonimbus clouds. And also in the air, clouds could cause turbulence. So you could see the aircraft flying on top of the clouds, cruising on top of the cloud, but because of the convection, experience turbulence. You could see passengers in the aircraft and things being thrown around and could destroy things in the aircraft. So it is very good for the pilot to be able to know what he or she is expected to encounter on the cruising path or along its route, so that if they will be dangerous, an alternate route could be chosen. Then we have also what is called wake turbulence. This wake turbulence is not associated with weather per se, but what it does is behind the aircraft, there used to be quail winds. So you could see in the left picture, you could see an aircraft, a smaller aircraft behind bigger aircraft, the left bottom. You could see a small aircraft behind a bigger aircraft. And when such thing happens, serious turbulence and damages could be caused in the aircraft that is behind. So it is very advisable that aircrafts could allow some distance away from another operating aircraft. Wake turbulence can also cause structural damage to aircraft. That's the jet blast. So some airports, they've written jet blasts to show that that area just behind the aircraft should be avoided because a very strong current of wind used to come out behind the aircraft and can even blow human beings away. Then we look at line squall. Line squall, this are chain of thunder clouds that can affect a place, and it is associated with very strong wind. And if information of this kind of system is not provided at the airport, then this is what could happen. You see on the right side, some aircraft, especially the smaller ones, some are blown down due to the strong winds that affected the station. So in times like this, we expect the forecasters and the workers at the airport to provide aerodrome warning so that those on the ground will also be able to use that information to reduce damages and incidents at the aerodrome. Then hail. Recently, or of late, we have been experiencing hail in Ghana. Some localities have reported hail, and if such things should occur at the airport, these are some of the damages that would happen. It could break the windscreen of the aircraft and damage even the front of the aircraft if it is encountered, if hail should be encountered during landing or takeoff. So we should be able to provide such information to flight operators. Then turbulence can also happen in the clear air. It can happen over places where there are even no cloud. They usually occur around jet streams. We'll be looking at jet streams on the next slide. Turbulence. The air can be clear, but the aircraft will experience turbulence whereby there will be shaking, and which could result in panic. Passengers could panic. They will experience free fall, and it could be a bit dangerous or worrying to our clients, passengers, and even stakeholders. We look at jet streams. We say jet streams are relatively narrow bands of strong wind in the upper levels of the atmosphere. So before entering the jet stream, these are the places where the turbulence could be experienced because winds of more than 80 knots could be experienced within the jet stream. And jet streams can also be quite useful if they are in the same direction of the flight path. It could increase the speed of the aircraft and will also reduce the time of flight. But when it is opposed, then it will have to increase the flight time and could also increase the usage of fuel. So information on jet streams to flight operators is very, very necessary in the aviation industry. And we look at visibility. There are instruments used for measuring visibility. And one thing is that not only visibility, but if an instrument is installed at the airport, it is advisable that the service providers, those that will use the equipment in providing the service, should know where those instruments are, should know how those instruments function. They should have display. They should have access to the information because they are going to provide the information. If an instrument is fixed at the Kumasi airport and they said it can only be accessed at the Accra headquarters, then those providing the services, how will they be able to provide the service? So I'll recommend that when instruments are being fixed for aeronautical purposes, let those who will be using it be involved, know how to use it, and know how to service them. They should be able to know when such equipment will not be providing very accurate information so that they will be very well. This is some incident that happened at the Kotoka International Airport some time ago due to bad visibility, deterioration in visibility. So during that times, we should be able to provide the representative information. If visibility is 200 meters, we should be able to provide that it is 200 meters and let them know that it is 200 meters in order to avoid some of these fatalities within our airspace, within our airports, and in our flight information region, and in the international aviation industry as a whole. Then fog is also quite dangerous. It reduces visibility. It's made up of water droplets in the atmosphere. So it will be difficult for an aircraft to see the ground. So at that time, measures are being put in place on the runway. So on the right side of the screen, you could see lights lit on the runway in order to aid an aircraft that is approaching to be able to land very well. On the right bottom, see some aircraft destroyed due to bad visibility at the airport. So we have to take visibility very seriously. Haze is also dust suspension in the atmosphere, which also reduces visibility. Recently, a flight was cancelled at Wa, and due to bad visibility. So we should make sure that during such times, we collaborate with our stakeholders and come out with very good representation. Observations should be done very well. The atmosphere well described, and forecasts appended to the information. The META should have a trend forecast in order to help in landing and takeoff. So there's also a satellite imagery called RGB, has satellite imagery, which is able to identify gas. So we have access to satellites that will be able to identify clouds, rain, and dust as well. So you can see over Niger, that's where the dust source region is located over West African sub-region, and you can see it's propagating southwestwards to affect the Guinea coast, Ghana, Nigeria. So during that time, visibility was very poor. So we also look at flooding on the runway. I'll advise that when good observations are made, information on the runway could also be provided so that if it would be possible, means would be found to clear the water on the runway. So we have to provide a lot of information. GMet has to provide a lot of information. When the runway is flooded, the eye of the aircraft will not touch the ground, and it is likely that it will skid off the runway. So look at the right bottom, you can see an aircraft damaged due to flooding on the runway. So let's look at some realities. It is necessary to know that the Met Office is quite delicate. It's one of the most delicate establishments in the aviation industry, because anytime there is aircraft incident or accident, all eyes looks on Meteo. So let's be more cautious in our offices. The duty forecaster, the officer in charge, would be intimidated by questioning, explanation. It has happened before. So let's make sure that we provide the actual information at the times that we are supposed to do. Then we should also be able to transmit our messages and keep copies in the office for some period of time, because those documents could be needed for investigations during search and rescue processes. Then forgetfulness and failure to report the representative weather condition at the airport on time, and even making prediction to the observed information like the META, the Met report. They should have some trend forecast which would help in planning. If these things are not attached, or this information does not go out early, then there will be late planning. So just imagine an aircraft flying from one place to another airport, only to reach there and realize that it will not be able to land because of deteriorated visibility, thunderstorms, or heavy rain. Then you could see how much will be lost in the industry. So forecasts, very good forecasts, will help in making plan in order to reduce loss or financial costs. Then we also try to look at the Earth's rotation. This rotation and revolution of the Earth causes changes in the weather. So it's advisable that we keep this movement of the Earth in mind, so that it will help us in making our forecasts. And also traveling to places, one should be able to know the season and the type of clothing or dressing that would be needed when one travels from one place to the other. So the distance of the Earth from the sun would help us to realize how the weather could be. If the Earth is closer to the Earth, then it means that place will be warm. When the Earth is further away from the sun, then it means that that place could be a little bit cold. So we have to know these things in advance. Then the seasons of Africa, there are mostly two seasons, the rainy season and the dry season. And flying aircraft in this kind of weather conditions are some of the things that we just looked at. During the rainy season, we have the intertropical convergence zone that are inland of the African continent. So the Guinea coast receives so much moisture and gets so much rain. During the dry season, when the intertropical convergence zone shifts southwards, we get mostly the dry winds from the Sahara Desert, which moves southwards and carries a lot of dust, very dry conditions, and that's the harmattan that we experience over the West African sub-region, whilst others would also be experiencing tropical cyclones within Mozambique and Madagascar area. The southeast of the continent receives tropical cyclones. So we should be able to consider these conditions whenever we are involved in flight operations. GMet establishes and implements a properly organized quality system. So failure to implement this quality management system could result or could affect the accuracy of measurement, observations, forecasts. So we have to take the quality management systems seriously, whereby we document processes and make sure that information that we provide present the geographical and spatial coverage. Formats of providing the information. There are laid down formats and content that a meteorologist should provide for an aircraft. When one deviates from that format, then it means that the QMS is not being practiced. So the time, the frequency, and even the period of validity of our forecast should be adhered to in order to provide safety. So in observations for aircraft operations, usually the interaction between the observer or the meteorologist and the pilot are routine. So locally, Met report is provided at the airport and local special reports, which is called a SPECI. Then also routine, which is called META, Met Aerodrome Report, are provided for aircrafts that are planning to come to an airport. So an observation is made, Met report is extracted from that same observation. There are other forms of observations or other forms of Met reporting, but for aviation purposes, we use the META routinely, and they must be broadcast to aircraft in flight through volmet and devolmet. And when we talk about observation, the Met observer is on ground. So there is a chance for the pilot to also give report, that's the RF, provide report to meteorologists at the airport. And this thing could be done on request. So it's advisable that meteorologists, practicing meteorologists, duty meteorologists, should liaise with the air traffic controllers to get this information from the pilot so that they would be able to streamline whatever information they provide to the aircraft. So in observation, we report our messages in code. So these are some of the weather conditions that we mostly experience: drizzle, rain, hail, fog, mist, sandstorm, storm. When you observe them, you have to report them. There are times to whereby some occurrence, some weather condition will be taking place, but not at the airport, but in the vicinity. It's very advisable to provide this information. Let the pilot know that it is raining, but not at the airport. So when such thing happens, you can tell him rain in the vicinity. Then the nature of like blowing dust, blowing sand, you should be able to tell us, tell the pilot whether the sand is drifting, fog, whether shallow. Let's be able to describe it. There could be partial fog at the airport. There could be patches of fog at the airport. Just try and provide this information. Then the intensity of present weather condition like rain. you should be able to tell the pilot whether the rain is slight, whether it is moderate or it is heavy, so that they will incorporate it in their planning. Then for forecasts, the type of forecasts that are needed, let's look at some. The trend forecast, which is appended to the METAR routinely every 1 hour or every 30 minutes that an observation is made to be transmitted. It must be accompanied with a trend forecast that will be valid for at least 2 hours for the pilot to be able to use it as a landing forecast. Then we have the terminal aerodrome forecast. Then GMet should be provided for the flight information region. So anytime there is any adverse weather conditions that will affect flight operations within the flight information region, then the Met Watch Office should provide this information. And when the information is provided, it is the responsibility of the meteorologists to make sure that this information are available on the internet, on the various platforms for the users to be able to access them. We should provide aerodrome warnings, warning those on ground, those working on ground. If there would be rain, provide the information to them so that they will be able to handle goods and people's baggages on ground very well for them not to be wet. Then we also need area forecasts. Mostly in Ghana is being provided for the Air Force. Then we also need GMet. That's a forecast for low-level flight that will be flying below flight level 100, that's below 3,000 meters. And also GMet should also be provided for low-level flight. And we look at some forecasting techniques. Pressure is one of the easiest elements of weather that can be used in making forecasts. So when we consider pressure is one of the most useful elements in flight operations because it's being used to calculate the height of an aircraft from the ground when the aircraft is approaching the station for landing. So when a barometer is used in measuring the pressure on the surface and there's high pressure, what it means is that winds are converging at the upper level and subsiding. You can say the wind will converge at the upper level and sink and diverge at the surface. So when such a situation happens, fair weather conditions are expected. Such condition does not enhance massive cloud buildups to affect flight operations. So on a day that the pressure is high on the surface, aircrafts are free to fly. But when low pressure forms on the surface, what it means is that winds will be converging at the lower level. The winds will rise, form thick clouds, produce rain. So when pressures are low, then there's a likelihood there could be bad weather conditions. So these are some of the techniques that could be used in flight operations. Then let's look at reporting of meteorological information. In making observation, there is time to go out for observation. That time, that is when every observer is supposed to go out. So if an observer is prevented the time that he or she goes out to take observation, then it could affect the observation. And also when to transmit. Our equipment for transmission have time limit. If you are not able to transmit after 5 minutes, then it means that your message will not go into the internet. So we have to take these issues very seriously. If we want our observation to be seen by the users, to be intercepted by the users, every observation should be accompanied by a trend forecast, like the METAR and Met report, special reports. There is also time for writing a forecast, time to transmit. The time of writing the forecast matters because the reliability of the information could also depend on the time that the forecast was written, and that's why it is necessary to provide the time for the observation. Then in reporting, we report wind, visibility, present weather. All these reports are in coded forms. They are coded such that it is only the user and the service provider that understand these codes. And it could be because of security reasons, and also for global use, so that even if the information is provided by an English-speaking meteorologist, a Chinese-speaking meteorologists should also be able to understand, and vice versa. Then we advise that every message should be identified before transmitting. The message should be identified as well as the station where the message is meant for. So in the trend forecast, when appending trend, we expect that the forecaster should be able to indicate the expected onset, cessation, or change in intensity of one or more of the following weather phenomena or their combination. So if there should be freezing precipitation, please, you should be able to include it in the trend forecast, like hail should be present in your forecast. Moderate or heavy rain, including showers, thunderstorms, dust storms, storms. When such things are expected, we expect that they appear in the trend forecast so that to help pilot in planning before coming to the station. Then we look at briefing. Pilots are expected to be briefed. Flight briefings to pilots. Pilots must be briefed on meteorological conditions that will lead to safety issues. And this includes the latest available information on existing or expected meteorological conditions. So before the pilot leaves the airport, you have to tell him or her what is on ground, what he should expect. Then the weather along the route be flown. The meteorologist should know the route of the aircraft so that he will be able to provide that information. Then the aerodrome of intended landing, information on that aerodrome, information of that airport should be provided. So if an aircraft is leaving Kotoka International Airport for Heathrow Airport, the forecaster here should be able to provide the pilot with information on Heathrow and other alternate aerodromes so that he can use in planning. Provide information on en route hazard phenomena should also be provided, and issues on low-level flight, low level, because the aircraft will be landing and be taking off. So low-level information should also be provided for the pilot. Then we look at some of the charts that are being used for flight operations, and this information is provided by ICAO through numerical weather prediction. So we have the SIG weather chart, which is significant weather chart, which shows bad weather conditions at upper levels where flights could be cruising. Then we also have the upper wind and temperature chart, which would be able to tell the wind direction and speed and the temperature at certain altitudes in the atmosphere. Then there are some experimental forecasts on humidity, turbulence, icing, and cumulonimbus clouds presence in the atmosphere. Also, we have volcanic ash advisory to provide information on where there is volcanic eruption, and the volcanic ash could be able to affect flights on their routes. There are also tropical cyclone advisory to provide information on tropical cyclones so that aircraft could avoid such areas. There are two types of satellite imagery being used for the industry. We have the geostationary satellites and the polar orbiting satellites. Then this typical satellite imagery and infrared satellite imagery. There are different types of satellite imagery which we could use, but this particular one is from the geostationary satellite. So the satellite imagery could tell us the type of clouds. We could see the different types of, we could be able to identify different types of clouds and their movement, the motion of the clouds and storms if we animate it. So we have 10 main clouds, but the most dangerous is the cumulonimbus cloud, which could be avoided. So we have the cumulus, stratocumulus, stratus, cumulonimbus, altocumulus, altostratus, parastratus, stratus, and cirrocumulus. So these clouds all have their weather conditions, their occurrence, and what's expected to happen or occur. Then we also have cloud seeding. Supposing there are clouds, but not very active, some means could be made. The clouds could be seeded. They'll produce heavy rains. They could use an aircraft fly and spray the chemicals on it. We could use sulfur dioxide and nitrogen dioxide in doing these things. And when clouds are seeded, the result will be bad weather, which will affect flight operations. So we should be very cautious and know when such activities are taking place, so that aircraft will not fly to encounter them. We also have space weather, which could be dangerous to some gadgets in the aircraft. It could affect their GPS locations and other things. It could damage some of the equipment. So we should know when there would be such dangerous radiations in the atmosphere, so that we provide that information to pilots. So I would recommend that flying in bad weather is very dangerous, and if possible, it should be avoided. And I would also like to plead to the Met Office in Ghana here to put for the office to be well organized, observations taken at the right time, transmitted regularly for the information to be available to every user. The information that is provided is not used by only pilots. It could be used by passengers as well. It could be used by others, because it is weather information. So I'll advise that these reporting procedures are highly adhered to. Thank you very much for your time.
All right, thank you very much, Mr. Padi. Thank you for that nice presentation. We've basically seen the effects of weather on aviation, some of the hazards that are associated with weather in the aviation industry, and then we've also seen information provided by the Met institution to sort of deal with these hazards, to take care of all the various stages in flight, from takeoff to when you are en route or when you are landing. But these information are also supposed to be regulated and then standardized. You don't just send any information just like that. You have to follow some standards and regulations. All right, thank you very much for that presentation once again. So we'll leave time for questions and answers. I saw a comment in the chat box by Jake. So we'll start with that one. But if you have any question, kindly raise your hand or put the question in the chat box. We will read it, and then Mr. Padi will answer them. So we'll start with Jacob's question. He says, is GMet providing all the forecasts needed for aviation services? If not all, could you suggest why and probably ways to get those forecasts?
Okay, thank you very much. Yes, GMet is providing the forecast. Well, they are providing the forecast, but looking at some stations where there are no forecasters, some of the forecasts, like the trend forecast, is not provided because there is no forecaster at those stations, and no one has been empowered to provide such information. So I think not all the forecasts are being provided at all the airports.
Okay, thank you. Marian, your hand is up. Kindly go ahead with your question.
Yeah, Mr. Padi, thank you for the interesting presentation. You made mention of the fact that a forecaster must report weather in the vicinity to the pilot, whether from takeoff or en route. Now, my question is, what is the radius from the airport that the forecaster should be able to report that there is weather occurring in the vicinity? What's the radius from the airport? How far should it be?
Yeah.
Or how close should it be?
Yes, at least 5 kilometers away from the airport. If some phenomena is occurring within this radius, the forecaster, the observer should be able to report. And you see, this reporting would help forecast because, for instance, observation and realize that there and comes in. There are some information that would need to be provided. One, visibility would be reduced towards that direction. So in your report, it should reflect that visibility is not good in a particular direction. Then you tell us what is happening in the vicinity. When the pilot realizes that he can avoid that direction when he's coming to land at the airport. And that is why it's very necessary to report conditions in the vicinity.
So does GMet have a map, or let's say at every airport? I don't know whether to you or to the forecasters at GMet. Is there something like a map in which you know the radius or you know the towns within or the areas within that 5 kilometers that you are supposed to report? Are forecasters aware of these?
Yes, they are aware.
Okay.
And they have visibility point, which they use in estimating the surface visibility. So supposing you have a visibility point like a building structure, let's take, for instance, the Meridian Hotel. When you stand at the airport, Kotoka International Airport, you would be able to see the Meridian Hotel. Then you should know that the distance from where you are, since you are able to see 10 kilometers, then fine, your visibility could be 10 kilometers off. But on the occasion that you go out and you don't see that Meridian Hotel, that visibility point, which is 10 kilometers away from you, then of course, your visibility should not reach 10 kilometers.
Oh, okay, great. Thank you.
Yeah,
okay. I think there was a follow-up from Jacob. It has been answered in the chat, but if you want to throw more light on that one so that everybody here who probably has not read the comments, the chat will see it. So he was asking if there's a recommendation for capacity building with regards to the services provided for aviation by the Met Office.
Yes, there is, because you see, everyone that contributes to the activities of aviation needs safety. We have enough workers, service providers. They should be available. Look at an aircraft. When it takes off, those that are involved are quite renowned persons in the country or elsewhere, and safety have to be provided. So, Josh, it's very necessary.
All right, thank you very much. Please, do we have any other question for Mr. Padi? Okay, I think that's one from Erasmus. So are there differences between phenomena associated with cloud seeding from natural one?
No, they will not be. So they are not different. The usual thunderstorms, heavy rains, and things, they are the only weather conditions that would be associated. But with the seeding, the intensity would be quite stronger than natural rain would be light, moderate, or heavy. But with the seeding, the rain would be quite heavy rain. Is it okay?
Yes, okay. Erasmus, if you're okay with it or you have a follow-up, let us know. I think this one is a personal one. Are you able to give feedback on GMet's plans to provide services currently not provided to the aviation? So just like what Mr. Padi said, for the Kotoka International Airport, there are forecasters working in shifts at that airport. So all the information that he talked about are provided in that office. But there are some offices, airport offices in the country who don't have forecasters in these areas. And so trend forecast, for instance, which has to be appended to the meter, and the meter cannot be written in Accra. It has to be done at those airports. And so there should be a forecaster there who would add the trend forecast to the meter and then send to all the operators, whether the air traffic controller or even the flight operators. But because we don't have forecasters in these areas, then it becomes a problem. There's actually a process, in place to get meteorologists to all these areas to sort of take care of these challenges that we have. So there's actually something going on. Just that it's not happening at the moment. So please, is there any other question? The floor is still open for questions. It's now 11:13. We still have some time to take some questions. So if you have any question, please let us know. I think everyone is okay. So we'll end here. So thank you, Mr. Padi. Thank you very much for the presentation. Thank you very much.
Thank you, Mr. Joshua.
And then thank you all.
Thank you, Dr. Maya.
All right. So I think this is where we'll draw the curtains for today's meeting. We'll meet same time next month.